The Pythagorean theorem is a very helpful tool when dealing with problems involving right triangles. Quickly first, though, let's talk about right triangles. A right triangle means that there is one angle that is a right angle. These are considered the legs, the sides of that right triangle are considered the legs. And the side across from the right triangle, commonly known as C, is known as the hypotenuse. Simply stated, the Pythagorean theorem says that a squared in a right triangle, a squared plus b squared, will always equal c squared. And the converse, if a squared plus b squared equals c squared, it is a right triangle. If it doesn't equal c squared, then it is not. Let's start with a really basic example. If I have the sides 3, 4, and 5, because these are the two legs, 3 squared plus 4 squared must equal 5 squared in a right triangle. And since 9 plus 16 does in fact equal 25, yes, this is a right triangle. And yes, this is how we apply the Pythagorean theorem. And furthermore, this is a really famous Pythagorean triplet, it's called. 3, 4, 5. If I multiply both of those by 2, all of them by 2, I've got 6, 8, 10. These, you don't even have to do any math. You can just say, those are, in fact, arcs. Let's take a look at another example. Let's say that we know that one side, the legs, equal 16 and 30. What is the hypotenuse? To do this, we say 16 squared plus 30 squared is equal to c squared. We're plugging in for a squared plus b squared equals c squared. So 256 plus 900 has to equal c squared. When I add those together, I get 1,156 is equal to c squared. And to find out what c is, I take the square root of both sides, and I find out that c is 34. Sometimes, however, you're given one leg and the hypotenuse. So if the leg that you're given is 28, and the hypotenuse, I'm just going to write hypot, is 53, then we say a squared, 28 squared, we don't know the other leg, so we're calling it b squared, is equal to 53 squared. So let's just use a calculator to figure out that 28 squared, so 28 squared, oh no, let me even see where that is. It is 784. 784 plus b squared is equal to 53 squared, which is 2,809. I want to get b squared alone, so I'm going to subtract 784 from both sides. And I'm sorry I'm out of space, but I'm going to move to the side and say b squared is equal to 2,025. And when I take the square root of both of those, because that's how I can undo b squared, I find out that b is equal to 45. Come on. Oh well. that slide just gets skipped. No, it doesn't. Okay. Now, you could have a situation where you're given, let's just say that, there's one that doesn't come out exactly evenly. Let's say A, we don't know. B is 9. And C is 11. So we know that A squared plus 9 squared, which is 81, equals C squared, which is 121, because that's 11 squared. When I subtract from both sides, I find out A squared is equal to 40. When I take the square root of this, you can just hit the square root button on your calculator, and it is about 6.32. So we're going to say is about that, 6.32. So sometimes you have to round to the nearest tenth or hundredth or whatever. The one final thing I do want to say is that if the sides don't equal, if I say A is 11, B is 11, and C is 16, if 11 squared plus 11 squared doesn't equal, 16 squared, sorry, I erase that, 16 squared, so 121 plus 121 is equal to 242, and that is not 256, therefore it is not a right triangle. I think you get the drift. You do have to, in word problems, figure out what they're giving you, but all in all, this is what you need to know.